Morning students, myself Vijay Shankar from EC Department, Electronics and Communication Department, Chevrolet Engineering College. Today we are going to discuss about the topic basic operations on the signals. Basic operations on signals. We already discussed some of the basic operations on the signals. Time shifting, time reversal, time shifting and time reversal. Now taking the time scaling there. Time scaling. Time scaling may be time expansion or time compression. Time scaling may be time expansion or time compression. The time of scaling of a signal x of t can be accomplished by replacing the t by a into t. T by a into t. Okay. Mathematically, it can be expressed as y of t is equal to ax of a into t. See, the scaling is occur for the time signal, not the amplitude. So amplitude means for the signal x of t, there is a scaling a into x of t, that is the amplitude scale. Here we are using the x of a into t, scaling a to the time function. So time scaling, it can be expressed as y of t is equal to x into x of a into t, not the x into x of a into t. If a is greater than 1, it results time compression. If a is greater than 1, it results time compression by a factor of a, and if a is less than 1, it results in the time expansion by a factor a. By a factor a. How to see? If I am taking the x of a into t, the scaling for time, that a, if I am taking the x of a as 2t, whatever the example you are taking, the 2 into t, the scaling is multiplied here. For this case, the expansion occurs, not the expansion, is a compression. Compression. Okay. If x of t by 2, if x of t by 2 means multiplying with 1 by 2, the t is multiplied, t is scaling with 2, compression occurs. The same 2 you can divide with that time, the t by 2, then it is an expansion. Expansion. Okay. It's the same thing we are saying that if a is greater than 1, it results the time compression. It results the time compression by a factor a. If a is less than 1, is here the 1 by 2, but the 2, 1.5. It results the time expansion by a factor a. By a factor a, because with that transformation, a point at at in the signal x of t becomes a point at t in y of t. So the y of t is a response of the signal. If we take the y of t is equal to x of 2 into t, the signal x of t is compressed. How much it is? Minus 1 by 2. Minus 1 by 2 is a 0.5. Okay. and 3 by 2. What is a 3 by 2? It's a 1.5. So it reduces or it is compressed the half part. So 1 minus 1 by 2 is a minus 0.5 and the 3 is by 2 is a 1.5. Okay, the values is compressed here. Expansion. Expansion means the minus 1 increases to the minus 2. Means a minus 1 into 2. And 3 is increases here this up to the 6. Following my students. So expansion. How we can compression and how it is expand. Let it be take the values of graphical representation here. Take the sequences. I already told is a functional representation, sequence representation, and graphical representation and the tabular representation. Any signal can represent in the 4 ways. One is a graphical representation, functional representation, sequence representation, and another one is a tabulation method or the tabular method. Now, using this graphical representation, we can write it as a sequence, the sequence of. When we are going to write the sequence, definitely it is a discrete only. X of n is equal to the sequence. If it is x of t, right, it is a functional representation. X of t is equal to. What is the x of t at t is equal to minus 1? The 0 here. What is the x of t at t is equal to 0? Its value is 4. Okay, its value is 4. What is the x of t value at t is equal to 1? Here also it is a 4 only. It is also 4 because c is a value and up 2 is also 4 only. At t is equal to 2, the x of t value is 4. And at t is equal to 3, the x of t is a 0. The 0 value. And here also the 0. So x of t values we got. And now we can take the x of 2 into t. 2 into the t. 2 into minus 1. 2 into 0. 2 into 1. 2 into 2. And 2 into 3. According to that, the t values you can take the y of t. What is the y of t? Here the y of t is equal to x of t. The y of t becomes of x of 2 into t. It compressed to the values of by 2, 0 by 2 here, 1 by 2 here, 2 by 2 here, and 3 by 2. So 2 by 2 you'll get is a 1 here. Alright. Like that it is compressed. And expansion occurs at the same values, x of t. Here also you can substitute the x of t by 2. The t by 2 values. Later can explain the whiteboard. The given signal x of t up to it is a 4 and here the 4 and the 3. The values is a 2 t. Minus 1, 0, 1 and 2 and it is a 3. 3 is a 0 given. And the magnitude is of x of t for 0, 1 and the 2 is a all is a 4. I'm drawing a dotted line here. Here also the 4 and 2 is also 4. This is a graphical representation given to find out the time scaling when it is a compressed and when it is a expanded. Compression occurs for the x of 2t. That will be the y of t is equal to x of 2 into t. Before to draw the graphical representation of x of 2t, write it as a functional representation. The functional representation of x of t. Okay. At t is equal to minus 1 at t is equal to minus 1. What is the x of t here? 0. X of t value is 0. X of t 0. At t is equal to nothing but x of t is 0. How can you say this? X of t is equal to x of the t as x of minus 1, that is equal to 0. Correct. And at t is equal to 0, x of t as x of 0, the value is a 4. And similarly for the t is equal to 1 also, the same x of t is x of 1. What is the magnitude here? So 4 is a magnitude. And t is equal to 2, the x of t, substituting the t, the x of 2 means here it's x of 2, the magnitude is a 4. And t is equal to 3, x of t is x of 3, the value is a 0. Value is 0 here. So minus 1, x of t is a 0, 0, 1, 2. For all three values of t, x of t is constant 4, and at the 3, at t is equal to 3, the x of t is a 0. This is a functional representation of x of t. Okay. Now, to draw this x of 2t, x of 2t means a is positive, a is greater than 1 in x of at, the scaling factor. In this case, it is expansion, not the expansion, it's a compression. If a is greater than 1, compress the signal y of t, the output signal. Before drawing the graphical representation, first of all, you can take the functional representation of the y of t when it is scaled by the 2 for the time. Okay. At t is equal to minus 1, at t is equal to minus 1, x of 2t. Now I am drawing the x of 2t, taking of a as 2. X of 2t is, what is the t I am taking the minus 1. So x of 2 into minus 1 and becomes of x of minus 2. What is the x of minus 2 value? There is no any x of minus 2, is a 0 only. The minus 2 is becomes here the 0. And 4 is also the 0 here. Okay. Three, 4, 5, all the values is the zeros. And minus 3, minus 4 is also the 0. X of minus 2, from the given signal, x of t, x of minus 2 is a 0. You get the 0 here. And t is equal to minus 1.5. I am taking minus, not the minus 1.5, minus 0.5. If I take minus 0.5, what is the x of t? X of 2t becomes 2 into t, that is equal to x of 2 into minus 0.5 as of 1 by 2. It is x of minus 1. X of minus 1. What is x of minus 1 value? 0. X of minus 1 is also the 0. And t is equal to 0. X of 2t is equal to x of 2 into 0 is x of 0 is equal to, what is x of 0 here? 4. Draw the 4. And t is equal to 1.5 can take. T is equal to, not the 1.5, t is equal to 0.5. t is equal to 0.5 x of 2 t becomes x of 2 into 0.5. It is a plus 0.5, my dear students. 0.5 means 1 by 2 x of 1. What is the x of 1 here? X of 1 is a 4. X of 1 value is 4. See here. X of 1 is a 4. And t is equal to 1 now. T is equal to 1. X of 2t is equal to x of 2 into 1. Means x of 2 is equal to, what is x of 2? Here, the x of 2 is a 4. Now, t is equal to 1.5 x of 2t becomes x of 2 into 1.5 into 1.5. What is the into 1.5? Becomes of 3 by 2 only. 2 into 1.5 is nothing but 3 by 2. 2 to get cancelled. It is x of 3. What is x of 3? 0. X of 3 is 0. So observe here. Finally, when I'm taking the minus 1 or minus 0.5, 0, 0.51, 1.5, still it is increases here. Still it is increases at 2. Definitely it becomes a 0 1. Already we got 0, 0 and 4, 4, 4 and the 0 also. Now let us see that also x of 2 into t is equal to x of 2 into 2. Because the t is equal to 2. X of 4. 4 is equal to 0. Means goes on increasing. The values is here 4, 0, 5, 0, 6, 0 and so on. Minus 2 is 0. What is a minus 3? Here it is x of minus 3. It is also 0. Whenever if we can take it is a t is equal to minus 1.5. Okay. Minus 1.5. And so on. So all the values is a 0. So it's a functional representation of the signal y is equal to x of 2t. Using these values, you can draw a graphical representation. Graphical representation, it will compress. Let us see that. At t is equal to minus 1, 0. Graphical representation of y of t is equal to x of 2t. Minus 2, minus 1. That I'm taking the minus 1, minus 0.5, 0, 0.5, 1, 1.5, 2, and so on. What is a minus 1? Minus 2 also we got, that is a minus 1.5. This one. You see, minus 1 is a 0 and minus 0.5 is also the 0. Minus 0.5 is a 0 here. Means previous this value is also the 0 and here also the 0. Minus 1 is a 0, minus 0.5 is also 0, and t is equal to 0. What is the value of x of 2t? X of 2t is a 4. X of 2t is a 4 here. That is a 4. Now I can join these 2 points, 0.5 to the 0. Then after, at t is equal to 0.5, x of 2t value is 4. 0.5 is also the 4. So, okay, it's a 4. If you got confusion, you can draw a dotted lines at the 0.5. And now, what is a 1 at t is equal to 1? X of 2t is a 4. T is equal to 1 also, the x of 2t is a 4. Up to the 1 here. Okay. If any confusion, you can draw the dotted lines here. And what is our t is equal to 1.5, x of 2t is 0. At t is equal to 1.5, x of 2t is a 0. So you can draw this. Now compare for this x of t, at the positive real axis, there is a x is equal to 3. And what is a half of the one here? Minus 0.5. And what is a half here? 3 by 2. Nothing but it is a 1.5. Means up to it is a compressed. You see, minus 0.5 is a 0 and 0 is a 4 and 1.5 is also 4, not the 1.5, 0.5 is also 4, 1 is also the 4 and 3, here whatever actually it is a 3, the maximum value in the x of t. But here we got the maximum is a minus 0.5. It's a compressed. Now when signal is compressed, when n a is greater than 1, taking in the x of at, that a value is greater than 1, compressed. The compressed signal. Okay. Now you can see what happens when if we can take y of t is equal to x of 1 by 2 into t. 1 by 2 into t. Here I am multiplying it with the 2 as a is greater than 1. And now I am taking the a is less than 1. A is less than 1, nothing but it is a 1 by 2. It is a 0.5 only. If the a is less than 1, in that condition it is expansion or compression there. 1 by 2 is multiplied for the t signal. That 1 by 2 is less than the 1. Whatever in the x of at. And you write the first of all the functional representation. What is a functional representation when t is equal to? When t is equal to, now I will start with because it is expansion occurs for this value. So I take the t is equal to minus 2, starting value. T is equal to minus 2. That t is equal to minus 2. What is the x of 1 by 2 into t? 1 by 2 into t is x of 1 by 2. Okay, my dear students, that is equal to 2 to get cancelled here, x of minus 1. X of minus 1. What is the value of x of minus 1? For the given x of minus 1 is a 0. X of minus 1 is a 0. X of minus 1 is a 0. Means that t is equal to minus 1. If I take that t is equal to minus 1, x of 1 by 2 into t. X of 1 by 2 into t, it becomes of 1 by 2 minus 1. 1 by 2 minus 1 is equal to, is x of minus 0.5. X of minus 0.5. What is the x of minus 0.5 here? Minus 0.5 is also not the value actually. It is a slowly it is increases. So minus 0.5 is a value. X of minus 0.5 is increased value. Okay, let it be the 2. Simply saying. Here it is a magnitude is a 4 means here the magnitude is a 2. Definitely it is a 2. Or it is increased with the 0 value. 0 and the 4, the half 0 plus 4 by the 2 is a 2 only. And let I am taking the t is equal to minus 1 is completed, the 0 if I am taking x of 1 by 2 into t is equal to x of 1 by 2 into 0. Okay, my dear students. X of 1 by 2 into t, that is what x of t, the x of 0. What is the x of 0 value? In the given signal, x of t is a 4. Let's take the 4 here. Understood, my students? So, and t is equal to, next value, if t is equal to 0 is completed, now I am taking the 1. T is equal to 1. What is the x of 1 by 2 into t becomes of x of 1 by 2 into 1 is equal to x of 0.5. X of 0.5. What is the x of 0.5? Is it in between of the 0 to 1 only? Here also the value is 4 only. Okay. So the value is a 4. At t is equal to 1 also. The x of 1 by 2 into t is a 4. And at t is equal to 2, what is the value? At t is equal to 2. So x of 1 by 2 into t becomes of x of 1 by 2 into 2. 2 to get cancelled. The value is x of 1. What is the x of 1 value? Again, it is a 4 in the given function. X of 1 is a 4. Now, if I take the x of t is equal to 3 also, the 4 only. T is equal to 3. X of 1 by 2 into t is becomes of x of 3 by 2. X of 3 by 2 is nothing but 1.5. What is the x of 1.5 value? Is 4 only. Why it is in between of 1 and 2? Between 1 and 2, the magnitude is also the 4 here. 0.5 is a 4 and 1.5 is also the 4. If you have any confusion here, you can draw as dotted lines to know the 0.5, the value is a 0.5 and 1.5, 1.5. And here the minus 1.5, minus 0.5. Definitely it is crosses at this point. Let it be the 2. The given function. The half part of the up to this is also the 2. So 2.5 is also will get 2 only. Understood, my students? So at t is equal to 3 is a 4 and t is equal to 4 means x of 2. At t is equal to 4, x of 1 by 2 into t is equal to x of 1 by 2 into 4 means it gets of x of 2. What is the x of 2? Is a 4 only. And t is equal to 5, 2.5. That is also 4. T is equal to 5. T is equal to 5. X of 1 by 2 into 5 is 5 by 2 is 2.5. X power of 2.5 is also 4. Then t is equal to 6. What is the t is equal to 6 now? The 1 by 2 into 6 is x of 3. That is a 0. Means at this value can end. Here the 0 is there. 2, 4, and the 1 is a 4 for t is equal to, not the t is equal to 4, this value, and t is equal to 1 is 4, t2 is equal to 4, t is equal to 3 is also 4, and t is equal to 4 is also 4, t is equal to 5 is also 4, and t is equal to 6 is a 0. Using this functional representation values of x of 1 by 2 into t, that 1 by 2 is scaling to the time, that a value is less than the 1. Okay, now I can draw a graphical representation using that functional representation values of the y of t is equal to x of 1 by 2 into t. Okay, in this, what are the values we find? -2, -1, 0, -2, -1, okay, -2, -1, 0, 1, 2, 3, 4, 5, and 6, and so on, the t value. Now, what is a -2? If t is equal to -2, the value is a 0. T is equal to -2, the value is a 0. And t is equal to -1, t is equal to -1, the value we got is a 2. Okay. 2 means here, the point. And at 0, for t is equal to 0, the value is 4. T is equal to 1, the value is 4. And t is equal to 2 is also 4. 3 is also 4. And 4 is also 4. And 5, 2.5. It is not the 2.5 is a 4, my dear students. 2.5 is a 2. 2.5, whatever we got, it is not the 4. Is 2, my dear students. Okay. So from the t is equal to 0 to the t is equal to 4, all the values is a 4 only. Means it is a constant value. 4, t is equal to 1 is also 4, t is equal to 2 is also 4, 3 is also 4, and 4 is also 4. Now what is a 5? At t is equal to 5, we got that t is equal to 5 is a 2 here. Okay. At t is equal to 5 is a 2. And t is equal to 6, what is the value? We got the 0. The 0. Now you can draw to join these points. Okay. Now you can observe y of t is equal to x of 1 by 2 into t is expanded or expansion. Expansion and the compression. Expansion occurs for a is less than values in x of at as a scaling to the time. And previously we see that it is compressed or compression occurs for a is greater than 1 in x of at. There is a compression occurs 1 by 2 is a 0.5. Here the 3 maximum for the x of t. 3 is the maximum. Is x of t. The 3 by 2 you will get it is a 3 by 2. 1.5. But in the y of t is equal to 1 by 2 into t, it increases or it is expands up to the -2 to the 6. So -1 becomes of -2 and 3 becomes of 6. Understood? So a is less than 1 in the time scaling. If that a is the scaling to the time, a value is less than 1, expansion occurs. If a is greater than 1 in the scaling of time, you'll get compression. Understood? Now you can go here. These are diagrams shown. X of t is the given function. In the y of t, x of 2t, x of 2t is a time compressed signal. For a transformation, y of t is equal to x of 2t. X of 2t here, the time compressed signal is shown. And for a transformation of y of t is equal to x of t by 2, the time expanded signal. See here, it is expanded up to the -2, and it is expanded up to the 6, from 3 to 6 here, and -1 to -2. But in the compression, -1 to the -0.5 and 3 to 1.5. Okay, like that, we're taking the A value is greater than and the A value is less than, compression and the expansion occurs for the given signal x of t by taking the scaling factor of A for the time signal t. Understood? The next topic in the signal addition. Basic operations on the signal. That is the next one is a signal addition. Until now we've seen the time, the basic operations on the signal, time shift, time reversal, and the time scaling. These are all three related to the time only. Only there is a changes occurs in the time, and the time reversal also only there is a changes occurs in the time, and the time scaling also only there is a changes occurs in the time only. There is no any change occurs in the amplitude. Okay, so coming to the amplitude scaling and the signal addition and the signal multiplication, here there is no any change in the time, but there is a changes occurs in the amplitude, nothing but in the y-axis. Let's see that signal addition. Signal addition. The sum of two continuous signals, x1 of t, x2 of t, can be obtained by adding their values at every instant of time. Similarly, the subtraction of one continuous time signal x2 of t from another signal x1 of t can be obtained by subtracting the value of x2 of t from that of x1 of t at every instant. Okay, there is a addition and subtraction, means that take the two signals x1 of t and x2 of t, you can add in the subtraction, there is a changes occurs in the amplitude obtained by adding their values at every instant of the time. Or similarly, the subtraction of one continuous time signal x2 of t from another signal x1 of t can be obtained by the subtracting the values of x2 of t from that of the x1 of t at every instant. Okay, let's consider the two signals x1 of t and x2 of t. Here is x1 of t and x2 of t given. So first of all, you can see adding of these two signals. So what the changes occurs in the amplitude, and adding subtraction of these two signals, what is the changes occurs in the amplitude, you can see. Now, see, first of all, you can write the functional representation. At t is equal to 0, what is the x1 of t? 2. At t is equal to 0, x1 of t is equal to 2. Okay, and here at t is equal to 0, what is the x2 of t? x2 of t is equal to, now see here, x2 of t is equal to 0, 1. Is a 0 point. Is a 2 magnitude. Okay, x2 of t is a 0. Now adding of these two signals, x1 of t plus x2 of t at t is equal to 0. Okay, at t is equal to 0. What is at t is equal to 0? x1 of t 2 plus, what is the x2 of t at t is equal to 0? The 0 value. 2 plus 0, the 2. the addition of the two signals x1 of t and x2 of t at t is equal to 0, the value is a 2 here. See, at t is equal to 0, the value is a 2. Understand, my students? Next, if I am taking at t is equal to 1. What is at t is equal to 1? x1 of t. x1 of t is equal to, see in this graph, at t is equal to 1 here, the magnitude is a 1. This is a magnitude 1, and here the magnitude is a 2. So at t is equal to 1, the magnitude is a 2 here. Understood, my students? 2. And at t is equal to 1, what is the x2 of t? See in this graph, at t is equal to 1, the magnitude is a 1 here. You see this one, 1. Now, to draw this x1 of t and x2 of t, at t is equal to 1, x1 of t plus x2 of t, at t is equal to 1. What is x1 of t? 2. At t is equal to 1. What is x2 of t? 1. So 2 plus 1 is a 3. Okay, means at the t is equal to 1, the magnitude of x1 of t plus x2 of t is a 3. You see here, is a 3. Got it, my dear students? At t is equal to 1, x1 of t is the value is a 2. At t is equal to 1, x2 of t value is a 1. And combining these two signals, at t is equal to 1, the 2 plus 1, nothing but the 3. 3 is the magnitude for x1 of t plus x2 of t. Following. Then take this, t is equal to 2. T is equal to 2. At t is equal to 2, what is the x1 of t here? x1 of t is equal to, you see, t is equal to x1 of t is a 1. The magnitude here, you see. At 1 is a 2, but at the 2, it is a 1. 1. And here at t is equal to 2, what is the x2 of t? x2 of t is, at t is equal to, the value is a 1 only here also. 1. Now, combining x1 of t and x2 of t, x1 of t plus x2 of t, at t is equal to 1, the value is 1 here. At t is equal to 1, x2 of t, the value is a 1. So 1 plus 1, the 2. Okay, you see here, at t is equal to 2, at t is equal to 2, in x1 of t plus x2 of t, what is the magnitude here? The 2. The magnitude is 2. This is a line of magnitude 2. And this is a line of the magnitude is a 3. The previously we got a 3. And coming to, understand my difference here? At t is equal to 2, x1 of t is a 1. At t is equal to 2, x2 of t is equal to 1. Combining these two at t is equal to 1, 1 plus 1 is a 2. We got the characteristics. At t is equal to 2, the magnitude of x1 of t plus x2 of t is a 2 here. Now we'll see the 3. At t is equal to 3, at t is equal to 3, what is the x1 of t? x1 of t, 3 means here the value is 1 and this is a 2. Take the peak value. So x1 of t is equal to 2. Then x2 of t at t is equal to 3. What is the value of x2 of t at t is equal to 3? This is a 3 here. Okay, here also 3 and this is a 3. What is the value? 1. Magnitude is a 1 here. So combining these two at t is equal to 3, we will get x1 of t plus x2 of t. Here the 2 value plus this value is a 1. Totally get the 3. See, for the 3 also, magnitude is a 3. Is a signal addition, x1 of t plus the x2 of t. Understand, my dear friends? Then take the last one at t is equal to 4. What is the x1 of t? x1 of t is a magnitude is a 2. And x2 of t at the t is equal to 4. So see, the t is equal to 4 means the value is a 0 here. 0. Now at t is equal to 4, x1 of t plus x2 of t, the combining of the signals, 2 plus 0, means totally the value is a 2. See, here at t is equal to 4, what is the magnitude? Is a 2 here. Got it, my dear friends? So taking off x1 of t and the x2 of t, each value of the t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3, and the t is equal to 4. The remaining values is a 0 zone. Minus 1, 5, and here also the minus 1, 5. The remaining all the values is a zeros. Got it? So otherwise, without writing all these things, simply see 2 here, 0 here. Totally you'll get the 2. At 1, the value is a 2. 1 means 2 plus 1 is a 3. Next at the 2, 1 and 1. 1 plus 1 is a 2 here. Next at the 3, 2 plus 1, 3. And at the 4, 2 plus 0. Nothing but it is a 2. This is a graph by adding all the two signals given here, x1 of t and the x2 of t. Okay, my dear students. Now, the subtraction x1 of t minus x2 of t. So I'm not writing all these values. So see directly at 0, at t is equal to 0. What is the value here? At t is equal to 0, the 2. At t is equal to 0, the value is a 0. Means x1 of t minus x2 of t we are performing here. x1 of t is a 2 value and x2 of t is a 0. 2 minus 0. 2 minus 0 is a 2. So means at t is equal to 0, the subtracting of these two signals will get at t is equal to 0, the magnitude is a 2. Following my dear students. Then next, if I am taking at t is equal to 1, at t is equal to 1, you see here, this is a t is equal to 1. What is the magnitude here? It is also the 2. Magnitude is 2. And at t is equal to 1, what is the magnitude here? 1. Okay, 1. Now at t is equal to 1, t is equal to 1, 2 minus 1. Okay, x1 of t minus x2 of t. What is a 2 minus 1? 1 only. You see, at t is equal to 1, the value, the magnitude is 1 here. It decreases. Understood, my students? Then I am taking that t is equal to 2. Here t is equal to 2. What is the magnitude here? 1. The value is the magnitude 1. And at t is equal to 2, what is the magnitude here? It is also the 1. Okay. Now I am subtracting of x1 of t and the x2 of t. 1 minus 1. 1 minus 1. What is the 1 minus 1 value? At t is equal to 2, x1 of t will get 1 and x2 of t will get 1 and 1 minus 1 is a 0. So 2 is a 0 here. Understand, my students? Now I am taking the another one, the t is equal to 3. t is equal to 3. What is the value here? T is equal to 3. The magnitude is a 2. And at t is equal to 3, what is the magnitude here? 1. Means at t is equal to 3, at t is equal to 3, x1 of t value is a 2 and the x2 of t value is a 1. So 2 minus 1. 2 minus 1 is a 1. So 3 is here. 3, the magnitude is a 1. And the last one, take here, at t is equal to 4, t is equal to 4, what is the magnitude? Magnitude is a 2. At t is equal to 4, the magnitude is 2. For x1 of t. And at t is equal to 4, what is the magnitude of x2 of t? It is a 0. It is a 0 here. To get t is equal to 4 for the signal of x2, x1 of t minus x2 of t, what is the x1 of t here? The 2 minus 0. 2 minus 0 is a 2. You see, for 4, x1 of t minus x2 of t is a 2. Got it, my dear students? Okay, without writing any functional representations, directly by seeing at t is equal to 0 here and the t is equal to 0 in this and t is equal to 0. What is the magnitude here and what is the magnitude? Subtract these two. Then we'll get the value 2 minus 0. 2 minus 0 and 2 minus 1 as a 1 and 1 minus 1 0 and 2 minus 1 1 and 2 minus 0 2. Got it, my dear students? See, in this way we can add the signals and the subtraction of the signals, the characteristics, the graphical representation changes like this. Okay, taking up these two signals, adding up two signals, we'll get these characteristics, and taking up these two signals, you can subtract, you'll get these characteristics. Understood? What change occurs here? There is no any change in the timer, 0 to 4 only, here also 0 to 4, 0 to 4 and 0 to 4. There is no any expansion occurs and there is no any compression occurs here because it is a addition, signal addition, only changes occurs in the amplitude only. Here the 2 is amplitude maximum and here the maximum is a 1 and after adding the maximum will get the 3. Okay, maximum is a 3, my dear students. In the subtraction is the 2 only, the maximum because it is a 0 and here the 2 and here it is a 0. 2 minus 0, the maximum will get the 2. Understood? Only changes occurs in the amplitude. There is no changes occurs in the time. In the time scaling, time shifting, time reversal. In these 3 only there is a changes occurs in the time. But in the signal addition, amplitude scaling and signal multiplication, changes occurs in only the amplitude. Changes occurs only in the amplitude, my dear students. Okay. Now see the last one here. Signal multiplication. Signal multiplication. The multiplication of two continuous time signals can be performed by multiplying their values at every instant. At every instant. Two continuous time signals, x1 of t and x2 of t, are multiplied as shown in this figure. See here, taking of x1 of t as an example and taking of x2 of t and multiply these two signals, what the values and what the amplitude is changes occurs. Let us see. I'm directly saying by the values here at t is equal to 0. You see the t is equal to 0. What is the value? 2. And if t is equal to 0, what is the value of x of 2? 1. Means at t is equal to 0, here the multiplication, signal multiplication, my dear student. Signal multiplication means 2 into the magnitude of x1 of t at t is equal to 0 is a 2, and the magnitude of x2 of t at t is equal to 0 is a 1. 2 into 1 becomes of 2. So see here, we got the 2 at t is equal to 0 in the multiplication characteristics, x1 of t and x2 of t. Coming to the t is equal to 1, okay, I will take the another one here. T is equal to 1. See, at t is equal to 1, what is the magnitude here? It is also the 2 only. Okay, and t is equal to 1, what is the magnitude here? It is a 1. Okay, in this also, the both 2 into 1 is a 2 in the multiplication factor. See, at t is equal to 1, here we got the magnitude is a 2 only after multiplying the two signals. And at t is equal to t is equal to t is equal to 2. What is it? T is equal to 2 here? The magnitude is 1 in x of t, x1 of t, and t is equal to 2. Here the magnitude is a 2. The magnitude is 2. So 1 into 2. 1 into 2. Here also the value is 2 only. 2. You see here the magnitude is a 2. Understood? And now at t is equal to 3, at t is equal to 3. So if we take any in between of 1 and 2 here and in between of 1 and 2, in between of 1 and 2 the value is 1 only here. In between of 1 and 2, here it is not the value of 1 and here not the value of 2. So half part of the 1 plus 2 is a 3, 1.5. Okay, 1.5. That wise we got a slow increasing here. The 1.5. Understood, my students? At t is equal to 3, what is the t is equal to 3? I'm taking another one. Take here. T is equal to 3. T is equal to 3, the value is 0 here for x1 of t, and t is equal to 3, the value is a 2. 0 into 2. What is a 0 into 2? So 0. So 0 here. 3 is a 0. Means the multiplication of two continuous time signals can be performed by the multiplying their values. Their values. Means these are the values. Their values at every instant. I take only the 0, 1, 2, 3 at specific instant only. Actually, how to take it is at every instant because it's a continuous time. You can take the 0.5, 1.5, 2.5 also. Okay, 1.5, 2.5. Then only you can show that there is a linearity is there from 1 to 2. 1 to 2 increases. See 1 here and this one is a 1.5. So 1 to the 1.5 is a 1.5 here. The magnitude is 1 here and this one is a 1.5. And then it is increases. Understood? Like that, we can take the any two signals, can multiply, then we'll get the changes occurs in the amplitude only. There is a changes occurs in the amplitude only. There is no changes occurs in the time here. The time is the same. 0 to 3. After multiplying also, we got 0 to 3 only. But there is a changes occurs in the amplitude. Okay, and this one amplitude is like this, and there is amplitude like this. But here there is a changes occurs in the amplitude function. What here saying for 0 less than or equal to t less than or equal to 1, because why they taking that is a range at every instant for a continuous time signal. In between of 0 to 1, x1 of t, see here, 0 to 1, x1 of t is a 2. 0 to 1, x1 of t is a 2. 0 to 1, x1 of t is a 1. x2 of t is a 1. Hence, x1 of t and x2 of t is a 2 into 1, that is a 2. In between, I take here the specific values only, specific values. But because it is a continuous time signals, I have to take every instant, means the range is 0 to t, less than or equal to t, less than or equal to 1, the value is a 2. Okay, so here also you got the 0 to 1, is a value is a magnitude is a 2 only. Then after, for 1 less than or equal to t, less than or equal to 2, see here, for this case, the magnitude is a 1. x1 of t magnitude is a 1, and x2 of t magnitude is increases. You see, slowly it is increases. Linear function. Linear function. So x1, x2 of t is 1 plus t minus 1. 1 plus t minus 1 means t changes 1.5, 1.3, 1.6 and 1.7. Slowly it increases. In this, you can substitute the t is equal to value. T 1.1, 1.2, 1.3, so on. According to that, we'll get the values. So, from 1 to 2, it is range is also the linear. Why we got this linear function means, here it is a multiplication factor is a 1 only. x1 of t is a 1, 1 with this linear function, 1 with this linear function, we get the linearity within this range of 1 to 2. Then the last case decreases 2 to 3 and 2 to 3, there is a decreasing value with multiplication factor after 2. So that gradually it is a decreases. Understood, my dear students? These are very important here. x2 of t is a 1 plus t minus 1. Or otherwise, directly by see this, z1 to 2, the value is a 1, and 1 to 2 it is a linear function. So this slope and this 1, it becomes all get the same slope here. From 1 to 2 on. Otherwise, you can use this formula 1 plus t minus 1. If t can substitute the t is equal to 1. 1 minus 1 is a 0, is a 1 here. And t is equal to 2, we can take a 1 plus 2 minus 1. 1 plus 2 minus 1 means here the 1 plus 1 is a 2. Otherwise, if it is in between of 1.1 and the 2, it's a 1.5. 1 plus 1.5 minus 1. 1.5, 1 plus 1.5 minus 1. In between the range, if I take 1.5 minus 1 is a 1 plus 0.5. What is a 1 plus 1.5? 1.5. These increases. Okay. Now it is a completion of the basic operations of the signals. Briefly, okay, see, these are the basic operations we completed: the time shifting, time reversal, time scaling, amplitude scaling, signal addition, and the signal multiplications. Okay, my dear students. Any doubts? Please rise. Okay, thank you. Thank you, one and all.